Chapter 5, Section 2, problem number 9. The probability that a standard normal random variable z takes a value in the union of intervals minus infinity to minus a in union with a to infinity, which arises in applications, will be denoted probability of z is less than or equal to a or z is greater than a. Use figure 12.2 to find the following probabilities of this type. Sketch the density curve with relevant regions shaded to illustrate the computation. Okay, let's look at this. So A, we're going to be this probability z. I've got my great straight line here again, right? So here's my slightly better normal distribution. I'm going to have minus 1.29, 1.29 positive. I'm looking at this area shaded and this area shaded. Oh, lovely writing there, isn't it? Okay, now because of symmetry, these two areas are going to be the same. So essentially what I'm going to be able to look at here is look up the probability that z is less than minus 1.29 and multiply that by 2. Because I look up the one and I add the other in one case. In this case, since they're symmetrical, I can multiply by 2 to do that. So I'm looking this up in the standard normal table there in 12.2, minus 1.29. I'm looking at row minus 1.2 over where the column is 0.9. So minus 1.29, that's going to be 0.0985 times 2 equals 0.1970. Okay, let's see if I can do better for this time in a straight line. A little better for a straight line. Let's get another standard normal here. And we're at minus 2.33, so that's further out. So everything out here shaded. Minus 2.33. I lost the minus sign. There it is. Out here, everything out there is plus 2.33. So likewise, I'm going to look at z. I'm going to put the little arrow on there. That's the way the Europeans do it. It's less than minus 2.33. Just going to double it because both tails are being looked at here, so we're having, and they're going to be equal. So we'll double our value. So we'll look that up. The probability that cumulative probability of z being less than minus 2.33. Once again, we're going to look at row minus 2.3 over to column 03. And that value is 0.0099, which makes sense because this is a smaller value. I've drawn it as a smaller amount, so the amount of probability there is less. This is 0.09, this is 0.0099. This is going to give me 0.0198. See if I can do this one any better. Nope, not really. We're at 0. And we're at minus 1.96. This is kind of between those other two. It's at plus 1.96. So here, I'm looking at this probability of both tails. So the probability that z is less than minus 1.96. Times 2 again, because we have both tails. I'm trying to make a little swirly there on the 2 for us. Look a little better. So the row minus 1.9 over to column 06 is 0.0250. There's a subtle thing to look at. So this value of z being minus 1.96 gives us the cumulative probability of 0.025. So we're looking at both tails. That gives us 0.05, 95% in and 5% out. that number will be coming up a lot. So you'll find that minus 1.96 or positive 1.96 to be something you see quite a bit as we go through the course, especially when we get on to confidence intervals later on. Okay, our third one here, let's try to draw one of my better ones. I need to change where my baseline is, don't I? So we're going to be way out here in the tail of minus 3.09. And I'll try to draw a little bit of shading out there. And here, positive 3.09. There's a little bit of shading out here. So again, the probability that z is less than minus 3.09 times 2. And we look at that probability, and again in row minus 3, minus 3.0 to column 0.09, 0.00, nope, yep, 10 times 2 equals 0.002. Does that make sense? This is the smallest amount, it's our smallest total. 0.129 is our largest amount, it's our largest total. Does make sense there. Except for the odd drawings and the funny z's that looked like 2's, we've got it.